Hi guys, welcome once again. We're back to another tutorial of Java. Today we just want to talk about data types. In Java. So basically, what happens in Java is that we've got, we might as well just get straight into it. Okay, we've got. I'll just give a bit of background. In Java, we've got 8 primitive data types, right? Um, you know, because what happens with Java is that it's a strongly typed programming language, meaning that, at least for those of us who've got a bit of a programming background, you understand that, like all the variables that you want to use, especially in Java, you have to have declared them. So that's what we're talking about when we talk about Java being a strongly typed programming language. So basically, we've got 8 primitive data types. 4 of them are integer types, which are we've got the byte, the short, the int, and the long. Um, you know, and well, with the byte, in fact, let's just kind of type it out here. Because you know what happens with Java is you really have to be typing for the most part. Okay, so we'll create a class. If you remember how we did it in the last tutorial, we'll call this class data types. Um, data types. Okay, yeah, this is an illegal character. It's not valid. So you'd rather use an underscore. Data types, and then make sure we're using Eclipse. Make sure we've got our main there, and inherited methods, etc. Just make sure we've got that. Yeah, so this is our class, because what happens in Java is everything has to happen in the class. I just like to delete this. These are just comments. You just take a look at them whenever you want to, and yeah, you just use them. So, with our 8 primitive data types, for the first one, we've got the byte. So byte, this is how you declare a byte. Byte, let's just kind of call it B, right? So here we've declared a byte. The thing with a byte is that its minimum value is -128 and maximum value is 128. It's an 8-bit value, right? The next integer data type we've got is short, right? And so with short, it's a 16-bit value. So basically what happens is the minimum value for the short is -32,768. Maximum is 32,767. This is how you declare the short. Let's just kind of call it short. We don't want to use the same word as short, because short is a keyword, and that becomes illegal. Yeah. The next type we've got is the int. This is a popular one. A lot of us use that. It's a 32-bit. It's a 32-bit data type. And then int. Let's just call it integer. Yeah, we declared that it's 32-bit. Well, it's quite a big value. It's about 2 million or something like that. Yeah. Okay. Well, not 2 million, 2 billion. Yeah. And then the last type we've got is the long. So, basically this is how you declare the long. And the long is 64-bit. I guess you can just kind of do the calculations, because, it's a really, really large number. I mean, that's like way more than a billion. We're talking trillions or whatever. Yeah, but that's a really large number. So basically what happens is when you declare these, it's just good programming practice to kind of understand the kind of memory that you're taking up, or at least the kind of variable that you would need, so that at least it just kind of helps you out when you're doing your declarations and stuff. Yeah. So those are 4 of the integer types, and then next up we have the float. Now the float You just kind of declare it the way you say it. Float FL, yeah, we declare that. Double, yeah, declare that. Let's call it DB. Yeah, so that's that with the float. The float is 32 bits, the double is 64 bits, so the double is basically the bigger version of the float. Yeah, and then the last, because now we've got 6, the last is the boolean, right? This is how you declare the boolean, just exactly the way you declare that. Let's call it BR. The boolean is basically, it's a data type that holds 2 values, either true or false, right? So yeah, it's basically, that's basically that. Let me just kind of show you how it works. Right, system, we just want to print out a boolean value. Okay, let's say we've declared, sorry, I like to work with integers. Int num1. You always want to give like meaningful names for your characters. Int num2. Yeah. And then what we'll do is system dot out dot println let's probably print out BL, right? But remember, we haven't assigned anything to BL, so let's just do this. Let's actually, what we had done here is we had done a declaration, but here we actually want to do a definition. 8 equal to 3, right? So what we'll do is we'll do a comparison, and then we'll store that in BL, right? Is assigned. Okay, so we'll ask is 8 greater than 3, right? We get a single value, right? So it's either true or false. So basically that's what we'll do, and then we'll just head over straight here, and then we'll run that. Okay, this wasn't actually meant to be part of the tutorial, but I just thought we'll just go through the boolean. True, you see, so that's exactly, it'll just print the value that we have in boolean, because BL it's a boolean variable. That's all it stores. It's either true or false. So if 8 is greater than 3, then we store the value in B1, and then we'll just kind of print out B1 right here. Exactly. So that's the boolean data type. And last but not least, we have the character data type. Character, you just kind of declare it as CHAR. Let's just call it CH. So that basically that's about that for data types. I've shown you how to declare these, because what happens is with all these primitive data types, you declare them exactly the same way. This is declaration. Yeah, this is definition. Yeah, so yeah, that's about that. Now we'll just move straight into the scope of the variable, right? So what happens is okay, before we do that, we were talking about declaration and definition. So some of you may have heard about assignment, right? It's basically, because what we've done here is we have declared this value num1, and then we've assigned it the value 8. So when you declare and assign at the same time, that's what we call the variable definition. That's when you declare here int num1 and actually assign a value at the same time, like simultaneously. But if, for example, we had just done something like this, right? We probably declare that num2, and then after that we talk about num2 is assigned 3. Exactly. Okay. So yeah, that'll be assignment, right? So here what we've done is we have done the definition. Here this is a declaration. This is an assignment, right? I'll probably just type that so that you can really understand what I'm saying. This, I said, is our definition, right? This, I said, is our declaration, and then this, I said, is our assignment. Yeah, well, not assignment like with the class type thing, but it's assigning. Yeah. Well, I mean, here we could have, it's still the same thing. We could have just said num1 greater than 3. It still gives you the same value. Greater than num2. It still gives us the same thing when we just go ahead and run that, and then yeah, basically get the same thing. All right. Next up, we want to move right into the scope of a variable. So what happens is that a variable is only valid within the blocks that it's been declared, right? And that's what we talk about when we talk about the scope of a variable. So like here we've got this block here. It comes like this and this here. So what happens is all these variables are valid anywhere within these within this block. That's the scope of the variable. I mean, unless of course we throw in some some extra stuff, like probably make it public or something. But for now, let's just keep it like that. Right? It's only accessible within the block that has been declared. Right? So it means what we're saying is that we can actually, like for example, talk about for we'll probably do some method right there where we say for int I is assigned 0, will continue for as long as I is less than 4, 5. Yeah, I plus plus. And then what we'll do right there is that we'll probably have a little block right there, block of statements. So do you know that I can actually now I can access this won't work. Never mind that. Yeah, I'd probably want to do a method. Yeah, let's talk about public int. That's the return type of the method, and then run. Right. Okay, so we've got a method right in there. What's there right there? Let's make this right. Public void. Oh, okay. We're on the main method. What am I doing? Oh, sorry guys, I've had a long day. Just about to write exams, so it's crazy. Anyway, yeah, I was trying to like do a method inside another method. Like you don't want to do that. Yeah, so we're still in the public class, and then we'll just do another. Yeah, so here we can do another variable that we could talk about, int. We can actually declare num1 again. Yeah, because what's happened here is we are no longer in this method right here. Okay, let me just delete the line so that you can probably see more clearly. Yeah. Okay, we are no longer in the main method because the main method starts here and it ends here, right? And then we start up a new method. So that's the block where these are valid. Where these are valid. And that's the scope of these variables, right? So they don't exist now when we're talking about this method here, method run. So in actual fact, you could start a whole new method. You can use the same variables, and there's not a problem there because you're talking about different blocks, and that's the scope of those variables. And then not lastly, we want to talk about typecasting. So basically what happens with typecasting is we're taking two different variables, and then we're kind of assigning one variable into a different data type. For example, right, there are two types of casts. We can talk about implicit and explicit casts. Implicit casts are when we are taking, if you remember the sizes I was talking about, we're taking a larger data type and assigning it into a smaller data type. Like for example here, int. Okay, let's use int, and then let's probably declare another one right here. Just remove this. Okay, byte, right? Byte by. So supposing we do something like this, 5, right? When we so when we take num2 and then we assign it to the value or to the contents of by, that's an implicit cast. And if you remember our sizes, that's actually very much allowed, and that's an implicit cast. But it also happens sometimes that you want to take, like what, an integer value, right? And you want to store it in a float. Now apparently a float here would be larger than an int. So what you'd have to do is what we call an explicit cast, right? So you have to actually tell the compiler, the Java compiler, that look, I'm very sure of what I'm doing and I know what I'm doing and I actually want to do it, right? So, like for example, we take db and then we assign no, I'm sorry, that's an implicit. If you say db and you assign by, that's very legal. It's allowed. You can do that. It's not a problem. But when you take a larger value, let's just suppose we gave db, for example, 25.986078. All right, and then we want to put take num2, and then we want to assign it to db. Right, that is not allowed. Right. So what you'd have to do is you'd have to typecast. Right. And that's what we're talking about, the explicit cast, because these are actually different data types, because we've got a float there and we've got an integer. But what we want to do is we actually still want to have the same value. But what it means is that we're just going to cut off the rest of these values. And Java wants to ask us, and Java wants to make sure that we actually know what we're doing and it wasn't a mistake. So what we do is we do a type cast where we kind of force it to like chop off the last bits here, and then save this value into num2, and then by the time it's done with that, we'll just talk about num2 here. We tell it to print, and then basically what it will do is here we go, print num2. Okay, db has 25. What has happened there? Okay, num2 is an integer. db is a double. So we type cast here, the value 25 into num2, and then we get 5. Yeah, this is pretty weird. Oh, I know why. This statement here. Should have commented that out. Yeah, okay. Let's do that again. Okay, right. There's our result. Okay. Hey guys, please just make sure you don't make those mistakes. Usually as soon as you're done with whatever code, don't just like overwrite on top of another code. You just probably want to clear it up and start all over. But I hope this was helpful, and I will just finish off the tutorial with postfix and prefix. Right. So what happens is sometimes we have an instance where we just want to increment. If you remember our for loop, we were talking about plus plus, right? So in Java, there are different conventions that we can talk about, right? So here, for example, we've got num2, where num2 is now containing the value 25, right? If we say num2 plus plus, right? We just kind of run this. Check that out. We've still got 25, right? But what happens is if we actually take this, because what it's done is it's already added that. Okay, if we do that, see that? Now what has just happened there is that we've got 26, right? This is what we call postfix, right? Like when we talk about post independence and post whatever, it happens afterwards, right? So it fixes afterwards. So that's postfix. And then we also have what we call prefix. Prefix kind of happens before, where if you put that there, it will just like before it actually prints it out. So it's just plus plus and 26. Yeah, and then it'll just print the same thing. Yeah, so basically that's that. That's postfix and prefix. Guys, I hope this was educational. I just had a long day, so it's a bit of a drag, but I hope you got something. And I'll catch you in the next tutorial. Enjoy.